Hello, this is another lesson on 5.2 in the Big Ideas Math textbook, and it is the second lesson on ratio tables. And the essential question is the same. How can you find two ratios that describe the same relationship? And real quickly, I want to talk to you about the difference between a ratio and a fraction, or maybe the similarities, because they are so alike. I write a fraction like this, 1/3. So let's say that you have 1/3 of a pizza. That 1/3 that you're looking at, that's not a ratio. That's a number that tells you what part of the pizza that you have. And so when you see this, you would say, oh, you've got 1/3 of a pizza. But then if I write so this is a fraction, right? It's the fraction of the pizza. But then if I write the ratio that there is one pizza per every 3 people, right? Now I'm looking at it as a ratio of 1 to 3. So it is 1 to 3 of pizzas per people. Now, in the end, the amount of pizza that each person gets is the same. So I want you to think about when you see a fraction, unless you know the story behind it or you see some units, you can't really tell if it's going to be just a fraction or a ratio. So when you see 1/3, if it has a unit pizza next to it, we're just going to think of it as a fraction. It's just another number. But if I see 1/3 and there's pizza compared to people, right? How much pizza per person, that becomes a ratio because there are units with it that describe two different quantities, right? So now we're looking at a relationship between the pizza and the people. Not that you have a relationship with pizza, but you know what I mean. All right, so we wrote this yesterday. Equivalent ratios are simplified to equal fractions. So here's what I mean. If I have 2/4 and I have 1/2, I know those are equivalent ratios because 2/4 simplifies to 1/2. And we're looking for multiplication or division patterns to figure out if the ratios are equal. Okay, so here's something I want you to look at. This is in your textbook on page 202. So let's say you have a scrambled egg recipe. Here's what I love, that you can make 4 servings, 2 servings, 6 servings, 3, 5, or 9. Okay, that's a lot of different recipes, but the ratio for all of them should still be the same, right? Because the amount of milk you add and the eggs you add, there's a recipe, and you don't want to change the recipe because if you add too much milk, that's just going to be weird. And if you add too much egg, maybe it's just not going to have the right consistency. So let's say you have 14 friends that are coming over for brunch. Nobody wants to get up early. How can you use the table to make scrambled eggs for 15 people, right? Because it's you plus your 14 friends. So I want you to pause this video, take a look at the different serving size, and figure out how you can use all the different recipes, the A, B, C, D, E, and F, to make scrambled eggs that is just right for 15 people. Okay, so maybe you notice that you can start basically making batches and adding them together. So let me get one color like purple. So what if I add 4 servings plus 6 servings plus 5 servings, right? Is that enough for 15 people? Oh my gosh, it is, exactly. So I could make the recipe of A plus C plus E and add them all together. Okay, well, how about this? What if I'm looking for 15 people and I notice that the 9 plus the 6, so I could add C plus F. So you see that there's a bunch of different ways that we can make this recipe. Now I also want to think about something that maybe involves some subtraction, because let's say I want to add, let's see, what if I did this? Oh, if I did 5, if I did 9 plus 3, that's 12. Ooh, for this one I could add another batch, but what if I did this? So what if I did, clear this, okay, so how about, maybe this overcomplicates things. things, but what if I did this? What if I did the D plus the E plus the F, right? So now I have 3 plus 5 is 8 plus 9 is 17, which is really 2 more than I needed. So here's the thought. Could I do D plus E plus F, right? And then that equals 17, so I need to subtract the B from it. So you can see there's all kinds of combinations that I can make, keeping the same ratio, but using servings, right? So I want to think about servings as kind of a total column. And when I have that total column, I can do some very creative adding and subtracting to make just the right number of servings to feed any number of people, right? You could even, if you wanted to just make one serving, right? You could take this recipe and cut it in half. So I could do 2 eggs, right? That would be 2 eggs. That's half of 4. Ooh, and this would be 1/8 of a cup of milk. So I can even do some division, right? And I can serve eggs. I can serve brunch for almost any number of people. All right. So now here are the notes that I want you to write down for today. So the title of this section is Creating Part to Whole Ratio Tables. So far you've created ratio tables that are part to part. Today we'll look at a few examples that are part to whole. And so you want to create a ratio with part to part. If you remember how to do that, it's just basically making the boxes and labeling them. And then you add another row for the total. So that's going to be at the bottom. Then the total row could be the sum or it could be the difference of the part rows. And then the last thing is that you're going to use multiplication and division to find the relationship between the ratios. That's what I want you to write down. Okay, so now, of course, we're getting into our examples, and I want you to see that the first example, it's a little bit abstract because I'm not really telling you what's happening, but I want you to think about the eggs and the milk that you are adding and the number of servings. So let's pretend that A and the B could be the amount of eggs compared to milk, and the total is like the servings that we want to come up with. So I look at the information that I'm given, right? So I'm going to write that in blue. I'm given that the ratio of A to B is 2 to 3. I put 2 here, I put 3 here. And then I'm given when I add in all of the A's and all of the B's, I don't know how many I'll have at the end, I get a total that's 30. I'm putting it here. And the reason is that I know that the total that you see down here with the A plus the B, oops, sorry, I meant to use red. The total that you see down here has to be the amount of A that I would add to the amount of B. So this total has to be 5. And now, of course, I'm looking for a multiplication pattern. So what would I multiply 5 by to get 30? It's 6. So I can go ahead and add in a times 6 and a times 6. Everything in my table in that column of 2 to 3 now gets multiplied by 6. So I get 12 and I get 18. And the cool part is when I check my math, 12 plus 18 does equal 30. So I think I have it right. So A, like if this was milk, would be 12. And if it was eggs, it would be 18. And now we're coming to an OYO. So I want you to write down this table and pause the video and try this one on your own. But notice that this time, instead of adding the A plus the B, you are subtracting. All right, so I'm going to use blue to fill in the information that we need. We know the ratio is 11 to 5, and we know that A minus B equals 18. So that has to do, right? This has to do with the total. It's not this column here, because I hope you already figured out that 11 minus 5 has to be 6. So when I subtract 11 minus 5, I get 6. And now I'm looking for the multiplication pattern, and I'm using my total row, right? This is my total. Total sometimes means a sum. Total sometimes means a difference. This was also a total. Okay, so I can see that this is a times 3 pattern. So I multiply the A times 3 and the B times 3. So I get 33 and 15. And if I take 33 and subtract 15 from it, I do get 18. So the total for A is 33 and the total for B is 15. Okay, so it's kind of like a number puzzle with some of these. Let's look at the next example. Look at all these kids on bikes, super fun, but it gets a little confusing, so we want to read very carefully. When I read this, I see that 7 out of, oh, ding, ding, ding. Okay, it's already thinking, when I see the out of, I'm going to write the word total because I know out of is that ratio word that means total. 7 out of every 8 students surveyed owns a bike. So that means 7 have a bike. That means out of 8, that means 8 people were surveyed. That means the number who don't own a bike, right? This I had to fill in. I'm going to do everything that I had to figure out on my own in red. I had to figure out that if there were 7 students who have a bike out of 8, that must mean that there is one that doesn't. And then I keep reading, and it says the difference between the number of students who own a bike and those who do not is 72. So this is the 72 is my, excuse me, my grand total in the second column. And you know, when I do the difference, so here's the tricky part. The difference is between own, right? So it's own minus not own. So it's not 8 minus 1 equals 7. It is, I'm going to write this in red because I had to figure this out on my own. This is 7 minus 1 equals 6. That's the trickiest part of this table. I had to do the math to figure out the difference. I had to read the words to see that it was the difference between the number of students who own a bike and the number of students who do not. So now I see that this number is 6. When I look for the multiplication pattern, it is times 12. So I need to multiply all of the numbers in this table times 12 times 12. Oops, sorry, that looks like a plus. 7 times 12 is 84. 1 times 12 is 12. 8 times 12 is 96. I want to be careful and make sure I don't really use the total column anymore because I figured out the no bike column. And when I do 84 minus 12, right? So this is a subtraction problem. I get 72. Okay, now we're going to try one on your own. Here is the OYO. This is the fun one. The ratio of 3 numbers is 4 to 3 to 1. So I'm asking you, what is the greatest number? That means the biggest, right? So if the ratio is 4 to 3 to 1, that means this would represent the greatest, the middle, the least. And then it says the sum of the numbers is 64, but I'm going to put that over here because that's the actual number, not the ratio, right? So there's a difference. So this is going to be the ratio of the numbers, and this is going to be the actual numbers. So it makes sense for me to think about this as my total row. And when I add the 4 plus the 3 plus the 1, I get 8. That's my total when I add the ratio of those numbers. Still don't know the numbers, but I can look for a multiplication pattern. And when I multiply by 8, 8 times 8 is 64. That means I need to multiply all of the ratios times 8. This ratio times 8 to figure out what the numbers are. 4 times 8 is 32. 3 times 8 is 24. And 1 times 8 is 8. And guess what it asked me, right? Super important. I go back and I read the question. What is the greatest number? It doesn't ask me to just fill out the table. It asks me the greatest number. And the greatest number out of those 3 numbers is 32. That's my answer to that last OYO. Okay, and that's it. Good luck on the part to whole ratio tables.